Hey guys, just want to make a quick video. I apologize for not being able to be there today. I have a sick kid at the house, but hopefully we'll be back tomorrow. And if you guys have questions, obviously you can come in at sometime during the day and talk to me, or email me as well. But just a quick rundown, not going to take too long on this video, what today looks like. First of all, we do have a quiz. It'll be at the end of class, the last 45 minutes. You have to take that quiz, and it's only on trig equations. So before you take that quiz, there's a lot of things you can do. First thing is you have the bonus, which remember is the trig equations bonus, the evens, on that assignment that you guys did earlier that I checked last class, I believe. The evens bonus is due on test day, but if you want to work on those to prepare for the quiz, you're more than welcome to. We also have the verifying identities homework, just the odds that will be due next class. If you want to work on those, the key is posted already. You can just double check that you're doing those correctly. And remember the evens on those, on the verifying identities, is also a bonus. It will be done on test day. And then one thing you need to make sure you get is a memory test review. The sub will be able to hand that out to you here, probably sometime at the beginning of class. And what's going to happen next class, you guys have seen it on Canvas. This is a good test opportunity for you, it really is. The memory test review, I'll just pull it up. Here's the key. It's already posted on Canvas. And it's just basically you need to know that stuff. Just know all the different trig graphs. You can see here's all these graphs. And then we have the reciprocal of functions, all those identities. The sine over cosine is the same thing as tangent. Cosine over sine is the same as cotangent. And then some of those Pythagorean cofunctions and even odds. All that stuff that you guys they most likely know already. But we're just going to make sure that you have a good grasp of it on the memory test. The memory test will be 25 questions. It will not be the whole class period. It'll be a shortened version during the class. It won't take you very long. If you know what you're doing, you'll probably finish it fairly quickly. Just other couple things I want to highlight is that you can see on your paper is that we have just normal unit circle, evaluating trig functions. Don't forget about your inverses. That'll also be on the quiz. The only thing that's not on here directly is just doing like a normal triangle and finding sine, cosine, or tangent on that normal right triangle. Like day one stuff. The other thing I guess I want to make sure I emphasize is also know the quadrants for the inverse trig. Like for instance, this one down here, inverse tangent -1 is negative pi over 4. Because remember, inverse tangent and inverse sine are both in quadrants 1 and 4. They're answers. And then the answers for inverse cosine are in quadrant 1 or 2. So just make sure you know that as well. But if you have a grasp of this, then you should be great on that memory test. Okay, the other two things I want to talk about are the trig equations, because they're really important. So I had two problems I just wanted to mention. Say you had a problem like this. We've done problems similar to it, but in this case, instead of it saying sine of x equals some like root 3 over 2 or 1/2, it's inverse sine of x is equal to pi over 3. And I think the best way to do this one is if you want to get rid of this inverse sine, we just need to apply a sine on both sides. So you can see I have it highlighted in green, so we'd say sine of this inverse sine of x and sine of pi over 3. So if you take the inverse of something and then you take sine of that value, so inverse sine of x, and then take sine of that value, that angle, you're going to get right back to x. So now x is isolated. So really the only thing we're looking at, I'll move that over here so you can see it. So really the only thing we're concerned about is what's sine of pi over 3? Well, you use your hand trick or your unit circle or your table, you can get your root 3 over 2. Okay, the last problem I want to mention is a problem like this, I believe is on your homework. So on our homework, if you had this problem, I think it's number 35, there's a couple things I want to mention this problem. First of all, we have cosine, tangent, and secant. We want them all to be the same thing. All right, so one way is if you'd apply tangent sine over cosine and secant's 1 over cosine, now we've got at least to sines and cosines. And just like you've always done in algebra in the past, the way you want to clear fractions within an equation, for solving an equation, is to multiply by that common denominator. So you can see I said cosine times the left side of the equation, and cosine times the right side. So if you distribute that cosine in, you can see this becomes a cosine squared, this cosine are simplify, and then on the right side, we're all ending up with 1 as well. So now we have no more fractions. We see a cosine squared right here, and we see a sine. We want them to both be sines or both be cosines. That would be the ultimate goal. And we can use a Pythagorean identity right here for cosine squared, because sine squared plus cosine squared equals 1. If you move your sine squared over by subtracting, you would get your 1 minus sine squared that you can substitute in place of cosine squared of x. So here's our equation now. We'll take that 2 and we'll distribute it into our parentheses. And now what we want to do is we want to take this equation right here. We want to get it all over to one side. So move everything over to one side of the equation. Now notice, I didn't take the 2 and subtract it over and think about dividing with a variable and all that kind of thing. I'll get to that here in a little bit. But so we have this, and now it's just a factoring problem. Some of you use substitution, some of you just use the signs. Whatever you want to do, you're going to factor eventually to something like that. Set each one of those factors equal to 0. Solve them. And so we're looking at is what sine of what value gives us negative 1/2 and sine of what value gives us 1. All right, so we would end up with something like these two solutions. Move this out of the way. So you have 7 pi over 6, 11 pi over 6, and pi over 2. Now if you notice on the key, the 7 pi over 6 and 11 pi over 6 were in good shape. They were both there, but the pi over 2 was not. And that's what I wanted to discuss with you. This is actually an extraneous solution because if you go back to the very beginning of the equation, you can see we have a tangent and we have a secant. Pi over 2, if you plug it in, it's undefined at both of those positions. So pi over 2 would not produce an answer. So anytime you have a problem that has vertical asymptotes or has fractions, right? Like this, when you take the secant and make it a 1 over cosine, a variable in the denominator, and it's like a rational function from your algebra days, then you have to be careful and make sure you go back and check the solutions. Anytime you have like a tangent or a secant or a cosecant or a cotangent. So this solution right here, the pi over 2, is not part of our solutions. It's extraneous. Only this 7 pi over 6 and 11 pi over 6 would work. So I wanted to make sure I mentioned that to you guys. The other thing I want to mention real fast is never divide by a variable. So if you had a problem like if you had cosine squared x minus cosine of x, so that's equal to 0, we would not add this cosine and move it over to the right side. We would not do that because you're going to end up dividing. So if I did that, for instance, cosine squared of x equals cosine of x, and then you divide by cosine of x, you're dividing by a variable. And in algebra, we don't ever want to divide by a variable unless we know for sure that variable is not 0. So let me go back to the beginning here. So you have cosine squared x minus cosine of x equals 0. So instead of adding the cosine of x over, we would factor it out. You could take cosine of x out of both terms. So we'd have cosine of x left right here in our first position, because cosine of x times cosine of x is cosine squared. All right? And then minus 1 equals 0. So now we have two quantities, this cosine of x minus 1 right here in parentheses, and this cosine of x sitting out here in the front. And we can set each one of those pieces equal to 0. So there was a problem on your homework that was very similar to this. So obviously we would solve this out and finish it. I'll let you guys do that if you want. But there's a problem on your homework where you might have not gotten some of the solutions, and it's because you might have divided by that cosine or divided by that sine. Remember, never divide by a variable. All right, guys, I appreciate you guys, and again, I apologize for not being able to be there today. But if you need anything, don't hesitate to ask. Have a great day.